Hello friends, welcome to Bhavesirki online class.
Hello friends, we are going to see chapter number 25, Trigonometric Relations of Complementary Angles. My dear friends, if you have not seen part 2 of Basic Concepts of Trigonometry, I would suggest you will not start seeing this video. Even if you have seen that video, I would request you before going into this video, you should remember all the relations which were listed down towards the end of that video. I will just write down those relations. If you remember, it's fine. If I have relation of sine theta with its complementary angle, theta's complementary angle will be 90 minus theta. It will be equal to cos 90 minus theta. If I take cos theta, then it will be sine 90 minus theta. If it is sec theta, then it will be equal to its complementary angles cosec, that is cosec 90 minus theta. If I am having cosec theta over here, then its relation will be sec 90 minus theta. If I am having tan theta, then it will be cot 90 minus theta. Cot theta equals tan 90 minus theta. These many relations are useful to you in grade 9. I extended those two more relations which I am not opening up right now because we do not require those relations. We'll be using any one or more than one relations while solving this particular exercise. And remember, the heading itself mentions complementary angles. Now, I have taken question 1, sub question 1. I have to find out ratio of cos 22 degree over sin 68 degree. If you observe this 22 as well as 68, right? If you add up, you can add up mentally. It comes as 90. So these two are complementary angles of each other. What I am going to do, either of the angle which are complementary, one pair of complementary angle is given. So out of that, only one angle I will change. So instead of writing cos 22, I will write down sine over here. I am taking, remember, I am taking theta as 22. Remember, I am considering this as theta. Theta is 22. So the rule says cos theta is equal to sine 90 minus theta. Here theta acts as 22. So it will be 90 minus 22. Denominator I am not changing, I am keeping denominator as it is. Now what happens in the next line is 90 minus 22 is 68 degree. So this is sine 68 degree over sine 68 degree. And you know the basic rule of division, any number divided by itself other than 0, answer is 1. Sine 68 upon sine 68 will be 1. Key point. While solving such kind of problems, you have to see any one pair or more than one pair, that we shall talk about little later. You have one pair of angles is making complementary angles, and out of both angles, any one angle you will convert into other. Like here I have converted 22 as 90 minus 22. Both, do not convert both of them together, otherwise you will end up in a problem you will not able to solve further. Let us understand with one more example over here. Now, I have been given sine square 40 degree minus cos square 50 degree. I have to simplify this. I have to solve this particular thing. Now, as we discussed just now, that 40 degree and 50 degree, if I add them up, they are making sum as 90 degree. They are complementary angles. I am keeping sine square 40 as it is, and I am converting this. I am considering this as theta as on now. So cos square 50, cos theta, so will be converted as sine square 90 minus 50. This becomes sine square 40 degree minus sine square 40 degree. What happens here? You can see a number subtracted from itself, answer is 0. So this is your answer. Key point again, remember one pair of angle you have to find out such that they are complementary. You may be given two ratios. any one ratio you will convert into other ratio. Dear friends, I am taking sub question 7 from question 1 of exercise 25. It is given sin 15 degree into cos 15 degree minus cos 75 degree into sin 75 degree. Now there appears 4 angles, but actually one 15 degree, other 75 degree. 2 angles are given. You have to manually add them up. 15 plus 75 will make 90 degree. So what I am going to do, I am going to change either 15 to with respect to 90 or 75 with respect to 90. So if I look at this particular thing, I am considering 15 as theta. So this will become cos 90 minus theta. Theta is 15. 90 minus 15. So this much part will become cos 75. What about cos 15 then, sir? Of course, cos 15 will be written down as we discussed. I'll be converting 15. I'm considering 15 as theta. So it will be cos theta will be sin 90 minus theta. Here theta's value is 15. So it will be sin 75 degree. Over here, second term, I am not doing any changes in second term. Now it is pretty simple. You can see AB minus AB, means any number subtracted from itself, answer will be 0. So this is your final answer. Exercise 25, question 3, sub question 1. It states that prove that tan of 10 degree into tan of 15 degree into tan of 75 degree into tan of 80 degree equal to 1. Now we can see there are 4 different angles, 10, 15, 75, 80. Now if you are smart enough, you will observe this 10 and 80 will make a pair of complementary angles, as well as 15 and 75 will make one more pair of complementary angles. So in this case there are 2 pairs of complementary angles. That is one thing you have to observe. And secondly, this question is proved that, hence it is not start with solution, it will start with proof first thing. And whenever you are proving something, you take LHS and RHS. So here I am taking LHS, which reads like tan of 10 degree into tan of 15 degree into tan of 75 degree into tan of 80 degree. And when you observed, you have already concluded 10 and 80 are complementary angles. So for a while I am considering this as theta. I am converting 10 into cot. It will be cot 90 minus theta. Theta is 10 degree. So this becomes cot 80 degree. Now I am considering 15 as theta. So what will happen here? Cot of 90 minus 15. That is cot 75 degree. And remaining 2 terms, parts of the terms, remains as it is. Now you have to recall a simple property which we learned in the basic concepts also, that cot is equal to 1 upon 10. That means they are multiplicative inverse of each other. If I multiply 10 by cot, it will be equal to 1. So here I can see cot 80 degree multiplied by tan 80 degree. That will fetch me 1. If I multiply cos 75 by tan 75, it will also be 1. So 1 into 1 is 1. So your LHS is 1. Even RHS is 1. Therefore I can say LHS equals RHS. And hence whatever they asked us to prove, we have proven it easily. One more question from question 3. They have asked us sin 42 into sec 48 plus cos 42 into cosec 48 equals 2. Now apparently this is very simple. 42 and 48 makes 90 degree, but before that we shall see something very important step. This is sin 42 into sec 48 plus cos 42 into cosec 48. If you remember, sec is a multiplicative inverse of cos. So sine 42 multiplied by sec 48 can be written down as 1 upon cos 48. Here cosec 48 can be written down as 1 upon sine 48. Now something, as you have observed, 42 and 48 are complementary angles. Any one angle I am taking as theta. Say example, I am taking 48 as theta. Then sine 42 I am keeping as it is. This 48 I want to change it to the related complementary angle. So I have to write down 90 minus 48, but cos will change to sine. What happens here? Cos of 42 over, I am changing this 90 minus 48. Ratio will change to sine to cos. Now this is sine 42 over sine 42 plus cos 42 over cos 42. Any number divided by itself other than 0 is 1. Same thing applicable over here. 1 plus 1, which will be equal to 2. This is the value of left hand side. Right hand side is also 2. So I can conclude left hand side equals right hand side. Question 5, sub question 1. For a triangle ABC, we are supposed to prove that sine of A plus B over 2 equals cos of C by 2. Let me tell you, it's a totally different kind of question. It's not difficult one, but totally different kind of question. If I start with the proof, I will talk about property of a triangle, that sum of all angles of a triangle is 180. I'm not writing the reason, my dear friends. I'm not representing this question exactly as what is required in exams due to lack of space. So angle A plus angle B plus angle C equal to 180. Of course, you have to mention the reason. I'm repeating that sum of all angles of a triangle is 180. I'm dividing both sides by 2. Dividing both sides by 2. What will happen? Angle A plus angle B plus angle C whole divided by 2 is equal to 180 divided by 2, which is equal to 90 degree. If I split it up, then angle A upon 2 plus angle B upon 2 plus angle C upon 2 will be equal to 90 degree. I am taking this part on right hand side, so what I get is angle A upon 2 plus angle B upon 2 is equal to 90 minus C upon 2. This is something very important result we have fetched, because when I'm going to prove something from the left hand side to right hand side, this will act as a catalyst. Unless and until you have done this, you're not able to do the proof part of the thing, of the given part. I'm talking about LHS. It is sine of A plus B upon 2. If I split it up, it reads like sine of A upon 2 plus B upon 2. Now I told you this part acts as a catalyst for this particular question. So sine, instead of A upon 2 plus B upon 2, I am writing it down as 90 minus C upon 2. And my dear friends, if I consider this as theta, sine 90 minus theta, sine 90 minus theta is cos theta. So this will become cos C by 2. This is your LHS. Look at the RHS. What is RHS? Cos C by 2. Hence, LHS equals RHS. I am explaining you this one more time. You already know that cos theta is equal to sine 90 minus theta. Till now we have used the property this way. In all the cases, previous cases, we use property this way. Left to right we have gone. Here we have gone from right to left. Cos sine 90 minus theta is cos theta. You can understand the sine 90 minus C by 2 is cos C by 2. This part is very important in this particular question. There is sub question 2 also. I will suggest you will try it out yourself. It's not difficult if you have understood this particular question. Question 6 says that find the value of the following. In that question, sub question 3rd, we are talking about sine 80 over cos 10 plus sine 59 into sec 31. There are two terms. One term second term. In first term, 80 and 10 are complementary angles. So I will consider one angle as a theta. So if I consider 10 degree as theta, this will become sine of 90 minus theta, that is 90 minus 10. So this will be sine of 80 degree over sine of 80 degree, which is equal to 1. What happens to the second term? That we shall see. Sine 59 degree into, if you remember sec and cos relation, sec and cos are multiplicative inverse of each other. So instead of sec 31, I have written down 1 upon cos 31. This becomes sine 59 multiplied by 1 upon this 31 I am considering as theta. So this will become sine 90 minus 31. This is sine 59 multiplied by 1 upon sine 59. This one remains as it is. Sine 59 into 1 upon sine 59 is 1. So 1 plus 1 becomes 2. Here there were two pairs of complementary angles. One as 80 and 10. Other pair was 59 and 31. Key point was converting sec 31 into 1 upon cos 31. Dear friends, I am going to take a very special question, and it's a different question than the questions which we have seen till now. They have given us evaluate or find the value of tan 55a minus cot 35 plus a. We have to evaluate the value of tan 55 minus a minus cot 35 plus a. Now, if you observe this very carefully, as I told you, you have a pair of angles. Mentally, if I add these two angles which I have underlined, 55 plus 35 will be 90. Negative a plus a will be equal to 0. So whatever underlying values of the angles, both the angles are complementary angles. Their sum is 90 degree. So what I am going to do is, any one angle I am considering as theta. Say for example, I am considering this as theta. Tan of 55 minus a minus, instead of cot 10, because I am writing 90 minus theta relation, 90 degree minus, instead of theta I have 35 plus a. This becomes tan 55 minus a minus 10, 90 minus 35 minus a. What will happen here is, first term remains as it is till now. See the second term, 90 minus 35 is 55. So tan 55 minus a. Any number subtracted from itself, answer is 0. So final answer of this particular question is 0. Very important. This is first time you are taking theta as a binomial. Till now, all the questions, only one number was taken as theta. Here theta was a binomial as 35 plus a. You have to be a little more careful. Not a difficult one, but a trickier question. Question 7, exercise 25. They given in triangle ABC, angle B is equal to 90, and we are supposed to find sec of A into sine C minus tan of A into tan C whole divided by sine B. Before going into this particular question, I would just write down angle A plus angle B plus angle C is equal to 180 degree. Out of that, angle B is known to us as 90, so angle A plus 90 degree plus angle C is equal to 180 degree. Therefore, angle A plus angle C is equal to 180 minus 90 degree. Therefore, I will able to say angle A plus angle C is equal to 90 degree. I am keeping C on other side. C is equal to 90 minus angle A. This is something very important result. Why it is important, that we shall see. Now, further going into solution, there are quite a few things happening together. What I am going to do, I am going to break up question into three parts. First part, I will look at sec A into sine C. Sec A into sine C. Sec A can be written down as 1 upon cos A. I hope you recall the multiplicative inverse concept. Sine C, I am writing it down as, instead of C, I am writing it down as 90 minus A. We have seen this result over here. 1 upon cos A remains as it is into sin 90 minus A is nothing else but cos A. I hope you remember this result, sin 90 minus theta, or rather I can call it as cos theta is equal to sin 90 minus theta. As we discussed in some question earlier, we generally use this kind of result. Here in this case we are using the reverse result. So 1 upon cos A into cos A becomes 1. So my dear friends, for your easier understanding, value of first part which we discussed, this entire part value is 1. Let us see the second part. Second part is what? Tan of A into tan of C. Tan of A as it is, tan of C can be replaced by tan of 90 minus A. And tan of 90 minus A is nothing else but cot A. And you should know the result that tan A into cot A, they are multiplicative inverse of each other, so this will result into 1. So something interesting coming into play. This is also 1. Now, sin B I am talking about. Sin B value, angle B is 90 degree. So sin B will be equal to sin 90 degree. And sine of 90 degree is 1. So dear friends, if you observe here, even this value is 1. So if I look at this entire fraction, it becomes 1 minus 1 divided by 1. 1 minus 1 is 0. 0 over 1 is 0. 0 divided by any non-zero number is equal to 0. So final answer after working so hard, you are getting 0. Answer 0, not mark 0. Exercise 25, question 8. They've asked us to find out angle A if sine of 90 minus 3A into cosec 42 equal to 1. Let us see the solution. Now this is sine 90 minus 3A into 1 upon into cosec 42 is equal to 1. Now we know that sine and cosec are multiplicative inverse of each other. So cosec 42 can be written down as 1 upon sine 42 is equal to 1. Now this sine 42, I am taking it on the other side. So sine 90 minus 3A is equal to sine 42. 1 multiplied by any number is number itself. So sine 90 minus 3 equal to sine 42. I am removing sine function from both sides. So what I get is 90 minus 3A is equal to 42. 42 I am bringing on other side. 90 minus 42 is equal to 3A. 90 minus 42 is 48. So 48 over 3 is equal to A. Therefore A is equal to 16. Key point here to remember, this cosec 42 was to be converted into sine 42, and this denominator had to be taken on the other side in the form of a multiplication. That's all from this chapter.